Hi! Today I will be going over problem +1. It reads, given a non-empty array of decimal digits representing a non-negative integer, increment 1 to the integer. The digits are stored such that the most significant digit is at the head of the list, and each element in the array contains a single digit. You may assume the integer does not contain any leading zero except the number 0 itself. So just to summarize the description, we're told that the array does contain something rather than having nothing. There is something to expect, and that the number that's going to be in that array will be a positive number, and we have to add 1 to that number. The next statement is that the digits are stored such that the most significant digit is at the head of the list. I imagine the head of the list would be at the first index. So that's the beginning of the array. That's my understanding of it. And each element in the array contains a single digit. So basically, for example, example 1 represents the digit 123. So it's broken down into its single digit, 1, 2, 3. So 1 would be its individual element, 2 would be another element, and 3 would be another element. That's what it's addressing, statement 2. The third statement, we may assume that the integer does not contain any leading zero except the number 0 itself. What that means is that starting from the beginning, we would expect the numbers to be of 1 or greater. So we don't expect like a 0, 1, 2, 3. That's what it's saying. Okay, so let's take a look at the examples quickly. So 123, adding 1 to that 124, that's our output. And adding 1 to 4,321 in example 2, we get 4,322. And adding 1 to 0 would give us 1. So this is pretty straightforward to understand. The related topic to this question is simply an array, and we don't really have to use any fancy data structure or manipulate it in weird ways. It really comes down to basic intuition, which I'll get to in a minute. I just want to point out that in terms of the interview questions, tech interview questions, this question is pretty relevant and very prevalent in companies such as Facebook, Google, Amazon, Apple, and Microsoft. So it's a good question to just have knowledge of. So without further ado, let's take a look at how this problem can be approached. Okay, so I have my solution written out here, and let's walk through the input examples, and I'll be explaining my intuition as I walk through. So starting off, the input 124, what happens is that so first off, we would be traversing the input array from end of array, so we're going from the right side, and we ask if digits divide, that is the current element. So in this case it's 4. Is 4 less than 9? Yes, it is. So digits divide would be incremented by 1. That's what the plus denotation is. So we add a 1 to the 4 and we end up with 125, and that's all we do. When the digits of I is less than 9, you can simply add 1 and return. Very simple. Now when one of those digits in our digits array happens to be 9, what happens is we need to replace the 9 with the 0, because as can be seen here, if we can recall from elementary school the carry 1 concept, in addition, what happens is 19 plus 1 is 20, so naturally in place of 9 we see a 0 here, so that's what we're doing. When digits of I is not less than 9, we have to replace the digits of I with 0, as can be seen here. So 9 plus 1 is 10, you have a carryover 1, and then you have a 0. So that's what the 0 here accounts for. And then 1 plus 1 is 2. So we replace the 9 with 0, and then we go back to the loop and we come to the index after the 9, which is holding the number 1 over here. And we see 1 is less than 9, so we add 1 to the number 1 in our digits array here, and we return the digits. So 1 plus 1 is 2, and we had previously replaced the 9 with 0, so that reflects our current, the true addition, which is 20. So this is a little different scenario where we're simply replacing the 9 with 0. Now the worst scenario is when all digits are 9, like in this example, 999 or 999, 9,999, whatever, right? So when all digits are 99, what happens is the place value changes. You can't simply just replace the 9s with 0s like we did here. The place value changes. So 99 plus 1 is 100. So again, carryover happens. 9 plus 1 is 10. So carry over 1 and a 0. And again, 9 plus 1 is 10. But we no longer have other digits to put the carryover 1 on top of. So we have to put the 10 besides the 0 here, which is 100, which is true. 99 plus 1 is 100. So what happens is when the place value changes, we need to accommodate that new place value. But the problem is that the digits array, it comes with the fixed size of digits. So if my digits are 124, it comes with 3 slots in my array. And if my digits are 99, it comes with 2 slots. But now that the place value changes, there rises a need to accommodate that new change with the new array size. So this is where the result variable comes in. So I would be creating a new array, and I would be making it of the size of the original array plus 1. And this whole new array is referenced inside this result variable. So I would be looping through my result array from backwards. So I would be adding zeros to all of my new slots, so which are 3 slots. So in the example 99, we would originally have 2 slots in our digits array. Now it would have 3 slots because we just created this new size, digits.length plus 1. Okay, so I would be adding zeros from right to left. And then what happened is I have to manually reset the first slot to 1 to reflect our addition here, so that we get the 1 here in 100. Otherwise it would just be 3 zeros, which is not correct. And we return the resulting array. So I hope this makes sense. Should you have further clarification, I'll be happy to address them down below. Now the time complexity is O of n, because we're only having a 1 pass along the input string. So therefore it is O of n. The space complexity, however, is when digits contain at least one not 9 digit, it is O of 1. But when digit contains all 9s, then it is O of n space time. Okay, so let's submit this on submit it on LeetCode. Okay, so let's run the code. So there you have it, and like I mentioned in all my videos, the LeetCode submission runtime is, for whatever reason, always inconsistent between each submission, although my code is exact same as I previously submitted. If you've ever experienced the same scenario, let me know down below, but this is a pretty efficient algorithm, and I just want to show that previously when I ran and submitted this algorithm, I had a runtime of 81%. However, now we see a 56.99%, so I tend to be cynical of LeetCode's runtime. I don't know which one to believe, but as far as my knowledge of my use case, I know that I'm not expending much of time or space complexity. But should you know why LeetCode has this inconsistency, let me know. But otherwise, please like and subscribe, as it helps me and encourages me to upload more relevant content and help each other out that way. Thank you.